Power set, T's and P's, airspeed's increasing. Looking for 75, gonna get past that bird.
Not long after getting my new 3-bladed propeller, I got a ding in it from a badly maintained taxiway, a nasty stroke of bad luck. It didn't happen here at Western, I should say, from where I'm flying today. And after swearing loudly on discovering said damage, I asked the engineers to do a repair. All's now good, but since losing a bit of metal from that propeller, from one of those blades, I've been getting a bit of a shake.
I don't know if you can feel this, I can certainly feel it. A vibration in the cockpit. I don't know if you can see it on the yoke here, and that's the vibration I've been getting.
You can probably see it a bit better if you look at the sun visor. A definite shake there. I was resigned to it until I found out there is something I can probably do to eliminate this irritation. I'm having the propeller dynamically balanced. I didn't know it was a thing, but it is a thing. And the lovely Ben and Charles from the propeller company Proptech have come from their base in Hampshire to here in Surrey to do that for me today. Now, I get a bit of vibration sometimes when I'm at all up weight. Sometimes the bulbs shake loose and stop working and I have to push them back in again. So I know there's a bit of vibration there. Could be the propeller, you think?
It's certainly worth considering the propeller, especially if you've had to have any sort of minor blend repairs, which could take out that factory static balance or MRO static balance that has been put into it.
Yeah, you mentioned the factory balance because I just assumed that it would come out of the factory balanced and ready to go. And I suppose it is to a large extent, but put it on the aeroplane and things change a bit?
They do. So with the static balance, it's done in a still air environment. The propeller isn't rotating, and that is just checking that at assembly it's been brought within a tolerance listed within the component maintenance manual. Once you attach it to the engine, you have to think of it a little bit like the tyres on a car and a wheel. So whenever you have your tyres changed at a garage, they then balance the assembly. So the tyre's been made and it is fully balanced as it's come up. The wheel's been fully balanced as it's been made by the manufacturer. Put the two together, you have to trim out the little bit differences between the two. So you're bringing the whole assembly, engine mount forward, into trim, into balance.
And what does a dynamic balance involve then? From what you've said, I gather we run the engine and see it in action.
Yes, so what we want to do is we want to bring the engine and propeller up to the most common stage of flight, so cruise, at that point where you're going to be spending the most amount of time, and we are then going to be taking vibration readings and attaching a small photo tachometer, a little light meter on the front of the engine, which is looking for rotation of the propeller, and that's going to give us a reading and say we've got a bit of vibration down here, so we need to apply some weight on this side of the spinner and see where that brings and try and bring us back in. Think of it a little bit like fine-tuning a television. You're just bringing that picture into sharper focus and taking it away from being that out of balance state.
Come to you, yeah?
Yeah, 1 second.
It didn't take long to attach the transducer, photo tachometer and a reflective sticker to the back of one of the propeller blades. The top cowling was reattached, all the cables were secured with speed tape and the handheld computer was programmed ready for the first test. Right, we're going to do our first run to see if they get a reading off of it. Okay, ready to start?
We're just warming up the engine at the moment. I want 100 degrees before I take it up to the power, and we're going to take it up to 2300 RPM, which is the normal cruise RPM. Red Hill Traffic Golf Bravo Mike India Victor is parked on the 18 run-up area adjacent to taxiway Echo for a high power engine run.
Once the engine had reached a safe temperature, I checked with Ben and Charles they were happy before powering up. I didn't want to be sat here on the ground at this power for very long at all, so I'm hoping they can get their readings done quickly, and I'm keeping a close eye on the CHTs and the oil temperature gauge. "20 seconds is all it took, and I was able to throttle back to idle again. And after giving enough time for the Arrow's turbo to run down, I shut the engine down and couldn't wait to see the results. So the computer recorded a vibration of 0.47 inches per second, which is officially classified as rough on the vibration scale.
It wants the majority of the weight just on the backside of blade number 2.
It recommended that the guys from Proptech add a 22-gram weight to the back of the spinner at the 130-degree point, which they did before we ran the engine once more. So apparently that first run and putting those weights where they did has halved the vibration already, and it's sort of right on the border of acceptable now. So the machine is saying to move the weights ever so slightly round, I think slightly reduce them, and that should hopefully get us exactly where we need to be. So we shall see. I don't know if, I think it felt a bit smoother, but it's difficult to know. I'm concentrating on cylinder head temperatures and maintaining RPM. So they've got that final balance right down to 0.01, which apparently is perfect. You can't get any better than that. So they're now putting the final permanent weight in exactly the right place on the back plate of the propeller, back plate of the hub.
Red Hill Tower, Golf Bravo Mike, India Victor, outbound with Papa, QNH 1018.
So after a total of 5 engine runs and the addition of a 23-gram weight, the balancing is complete, and it's time to go for a flight to see if we can see the results.
So Charles, we need to see how much smoother this is all is now after your day's work.
Charles is coming with me, and we're heading off to Proptech's workshop at Lyon Solent, where I'm going to see what goes into the propeller overhaul process.
So it's difficult to make a judgment, isn't it? We've got a bit of turbulence, a bit of thermals.
Yep.
But I guess we have to trust the computers, really, don't we? You know, they've told us that it had this significant vibration before, and it doesn't now.
Well, the thing is, it may not be a vibration that you can feel.
Right.
It may just be, you know, the wrong frequency, or maybe the airframe's vibrating at a different frequency, which is a higher amplitude, so you might not even feel the prop.
Yeah. But I suppose, you know, as comfort being a big part of what you're doing here, I don't imagine it's good that things vibrate when they don't need to.
Well, minimise everything as much as you can. The prop dynamic balance, if anything, is going to protect other components.
Yeah.
So it's going to be less wear on the engine, maybe a little bit less wear on the prop, and if it's amplifying through the airframe and making itself out to the end of the wing,
Yeah.
less stress going through those materials as well.
Yeah. Reds, blues, 3 grades.
500.
I found that the aircraft is noticeably smoother having had the balancing done, and I'm flying safe now in the knowledge that the propeller has gone from having an unacceptable vibration, potentially increasing wear, to having a negligible, almost undetectable vibration now. After my fairly sporty landing at Lyon Solent, I made the short hop to the Proptech workshop, which is on site here at the airport. So I've come onto the shop floor here at Proptech, an enormous workshop, and technicians are busy overhauling propellers in every corner, sanding, grinding, banging, inspecting, and we'll have a look at some of that in a moment. And I'm with Sophie Bone, who's the production manager. I think the CAA calls you maintenance manager,
yeah,
isn't
that's
it?
Right.
And you can't fail to notice this enormous propeller behind me. I'll walk up next to it and you can see how big it is next to me. It's probably 3 times my size. From an ATR, I think,
From
this
an
one.
ATR, yeah.
And that's a big part of what you do, isn't it?
Yeah, we have many blades in for ATR weekly. We have customers all around the world who require our support with their blades.
And what's happening with this one? This one's nearly done?
So this one's nearly done. It came on for overhaul. As you can see now, it's nearly finished, and we're at the point of it just requires balancing and then can be ready to be shipped to the customer.
Now, we've talked about the big metal
Yeah.
work. This is metal work, isn't
This
it?
is-
Yes.
No, this is composite.
It's composite,
This
okay.
is composite.
Which means it's layered up of different materials, is
Yeah,
that right?
that's right.
Because you can get them in all sorts of different
Yeah,
materials.
we can work from anything from wood to Kevlar to composites to aluminium. It's a variety of materials that get worked on
And we
here.
talked about the big stuff, but you do little stuff as well.
Yeah, we do anything from a wooden 2-blader through our GA customers, anywhere to our 6-blade propellers here.
I don't know about you, but I don't think I've ever been given much advice as a pilot and an aircraft owner when it comes to inspecting my propeller before flight. And so I'm using my visit to Proptech today to discover what to look out for when doing my daily walk around. So I've now come to the area of the workshop where propellers are stripped and then rebuilt. So sort of the beginning and the end of the process, I suppose, with Colin Choules, who's the CEO and accountable manager here at Proptech. And we've got a King Air blade here. That's right. And I thought it'd be really good to talk to you about, you know, when you're looking at your prop and you're trying to do your morning inspection or whatever, you know, what to be concerned about. And you thought this had a really good example. And I will say to you, I'm looking at this, and yes, I can see it looks a bit scuffed and a bit worn, but there's something more concerning on here that maybe doesn't immediately catch the eye.
Exactly. Yeah, so on the leading edge, we can feel a small but a definite chip. And
Right.
You can feel it with your fingers.
Right, I can see that, and there's a little circular dimple right on the leading edge.
Yeah, and you can.
That's typical of what we get.
It's a typical stone chip.
Yeah,
You can feel the raised material,
yeah,
and that means you need to think about what to do next.
right. I mean, I've got these on my blade, I'll be honest with you.
Yep.
Yeah, I'm not going to say which runway it was or taxiway it was, because some of them are really awful. And you come away fuming when you pick up a stone chip. I wouldn't be, as a pilot, and I don't think we're trained as pilots to identify, you know, what's concerning and what isn't on our props. I wouldn't be overly concerned about that. But you think that's something that needs attention?
I think the important thing is to be aware.
Yeah,
So there's no concern yet. It's still small,
yeah,
but you need to be aware of it and talk to your engineering team because if this was dressed now, it would solve problems further down the line.
dressed being.
So the sharp edges are removed using some abrasive, a file or other abrasive material. Dressed out, so smoothed out, and then you don't need to worry.
And if you don't do that, what are the consequences?
So the danger is, of course, that this will propagate. It will grow larger, and then a much more significant repair is required.
So how do we know that that's of concern, and maybe any other little? Because there's a few little. You can see it's got rough edges all along it. What makes that so concerning?
Simply because it does feel a bit bigger than
It stretched the material.
Yeah. So you can tell so much with your fingertips, and you can tell that this is an area that's a deeper and more pronounced chip than further along the blade.
And there's another example on this Macaulay blade here, probably a bit more obvious, partly because of the colouring. Again, the same problem.
Exactly. It's a pronounced stone chip on that blade, so that definitely needs addressing.
Is it something that would immediately ground the aeroplane until it's repaired?
No. So things like this is everyday stuff.
Yeah.
The important thing is to be aware of it, talk to your engineers, and it will probably be picked up at the next opportunity.
You can probably wait till then, ideally, but probably send them a picture and ask them. And if they don't really know for sure, I guess you can help too.
Yeah, always send us a photo. That's the best thing. We can tell an awful lot from a photo, and we could give you reassurance that you don't need to do very much. It certainly doesn't need a shop visit.
Talk to me about the propellers that come in here, the different types, and the work that you do on them when they come in for overhaul. If they can be overhauled, what do you do to them?
Well, so we're looking at a metal blade at the moment. So this propeller is fully stripped when it arrives. Every part is inspected visually and with NDT techniques. And we're looking for any damage that we can repair. And sometimes we have to replace parts that are irreparable. This blade would go through a complete strip, and at overhaul, we would be removing all of this damage, taking it back to a clean, bare state, and then rebuilding it back up.
And that's done on a metal blade, presumably by grinding, sanding.
Exactly. Yeah, you can hear in the background, our guys are sanding blades as we speak. So yeah, it's a large piece of the overhaul operation is to get the material back to a clean aerofoil shape.
You eventually get to the point where you've taken too much metal off and there's nothing more that can be done
Well,
with it.
that's of course the point about a metal blade. You're only ever removing material. So there's a lot of allowance, but eventually it will get to a state where it's below limits.
We've got a composite blade here. That's a different story when it comes to overhaul, is it?
Exactly. So with composite, we can apply new material. So if we had something similar to this damage, we can build that up with new composite.
Does that mean that composite blades always last longer?
It can do. There could be damage that's catastrophic on a composite blade, but a composite allows you to perform these material addition repairs.
Aside from the obvious, we've got the stone chips that you grind down and then the blade there's not enough metal left to repair it. What other things tend to fail propeller systems?
Moving away from the blades, we're always looking at the bearings in the blade into the hub. Bearings, seals, of course. Often seals are completely replaced at overhaul. And then we're looking at all components for corrosion and signs of degradation that either need to be addressed or sometimes replaced.
I think I've been taking my propeller for granted. I've kind of seen it as that spinny thing at the front of the aeroplane, which, as long as it keeps on spinning, I'm happy. But it's actually a very complex and clever component without which we'd be going nowhere, so perhaps we all should be taking more notice of it. It's been great working with the Proptech team to A, get my prop properly balanced, and B, to learn more about what they do here at their facility in Hampshire. If your propeller overhaul is coming up, I know they'd be pleased to serve you. Thank you for watching. Do please like and subscribe. You know the drill. It really does help the channel grow. And until next time, fly safely, my friends.